Let us now solve question number 55 of GATE 2017. The question is, tungsten nickel compact is prepared by liquid phase sintering at 1500 degrees Celsius if the size of the tungsten grains is 40 micrometers and the interfacial tungsten and tungsten nickel energies are 0.52 and 0.3 joules per meter square respectively. The predicted average nick size in micrometers of the sintered tungsten grain is to be found. The options given are 10 micrometers, 15 micrometers, 20 micrometers and 25 micrometers. And we are also provided with the melting points of tungsten and nickel, which are 3410 degrees Celsius and 1453 degrees Celsius respectively. So let us go for the solution. So let us assume both tungsten and nickel particles to be perfect spheres. Here the blue circles represent the tungsten particles and the red circles represent nickel particles. So when these particles are subjected to liquid phase sintering at 1500 degrees Celsius, all the nickel particles will be molten since the sintering temperature, that is 1500 degrees Celsius, exceeds the melting point of nickel, that is 1453 degrees Celsius. And as shown in this figure, the tungsten particles will be fused together on one side and will form a neck. And this is the neck size. And as I have already told, nickel will get molten and will be surrounding the sintered tungsten particles. And let us assume this neck size as x, which we need to find in this question. We are also provided with the interfacial energies of tungsten and tungsten nickel values, which are 0.52 and 0.3 joules per meter square. So the tungsten nickel interfacial energy gamma tungsten nickel will be 0.3 and the tungsten interfacial energy is 0.52 joules per meter square, and this angle formed is called as dihedral angle, which is theta. This value will be theta by 2 and this value will also be theta by 2. This length is nothing but the radius of the sphere, and here the angle formed will be theta by 2. So in order to find the neck size, we need to first find the dihedral angle, that is theta, from the given values of tungsten nickel and tungsten interfacial energies. So let us find the value of theta by 2, for which we need to write down the energy equation gamma tungsten nickel into cos theta by 2 plus gamma tungsten nickel cos theta by 2 minus gamma tungsten will be equal to 0. So the tungsten interfacial energy will be 2 times the interfacial energy of tungsten nickel into cos theta by 2. Theta by 2 will be cos inverse of tungsten interfacial energy divided by twice tungsten nickel interfacial energy. So let us substitute the values. The value of theta by 2 will be 29.92 degrees. So the value of dihedral angle is found. So let us find the value of neck size from this triangle. Let me redraw this portion. We know that this is a right angled triangle and this value is theta by 2 and this value is the radius of the tungsten particle, that is 20 micrometers, and this value is the neck size by 2, that is x by 2. The value of theta by 2 is 29.92 degrees. We shall find the value of x by trigonometric equations, for which we need to use sine function, that is sine theta by 2 will be the opposite side, that is x by 2 divided by the hypotenuse, that is 20. So sine of 29.92 will be equal to x by 40. So the value of neck size will be 40 into sin 29.92, which is 0.4987. So the value of neck size will be 19.95 micrometers, which is the answer. So from the given options, the correct answer for this question will be option C, that is 20 micrometers. Thank you.